Modern agriculture often presents itself as the peak of efficiency, a system refined by technology, data, and industrial scale. Machines plant faster, fertilizers promise higher yields, and irrigation systems deliver water with precision. On paper, it looks unbeatable. But when you step back and look at long-term sustainability, soil health, resilience to climate variability, and even total productivity per unit of land, something unexpected begins to emerge. Many indigenous raised bed systems, developed centuries ago without modern tools, don't just compete with these systems. In many cases, they outperform them. At first, that sounds counterintuitive. How could ancient methods rival techniques backed by science and engineering? But the answer lies in how these systems were designed. Indigenous agricultural practices were not built for short-term yield maximization. They were built for survival, continuity, and balance. They evolved over generations through direct interaction with the land, adapting to local climates, soil types, and water patterns. Raised bed systems, in particular, represent a level of ecological intelligence that modern agriculture is only beginning to fully appreciate. One of the most well-known examples comes from Mesoamerica, where farmers developed chinampas, often referred to as floating gardens. These were not random plots of land, but carefully constructed raised beds built in shallow lake systems. Layers of mud, vegetation, and organic matter were stacked to create fertile planting surfaces surrounded by water channels. At first glance, it might look simple, but the design solves multiple problems simultaneously. The surrounding water regulates temperature, reducing the risk of frost damage. It provides a constant source of moisture, minimizing the need for irrigation. And it acts as a nutrient reservoir, allowing organic matter to cycle naturally back into the soil. What makes systems like these so effective is that they operate as ecosystems rather than isolated plots. Modern planting systems often treat soil as a medium to hold plants, something to be supplemented with external inputs like chemical fertilizers. Indigenous raised beds, on the other hand, treat soil as a living system. Organic matter is continuously added, microorganisms thrive, and nutrients are recycled rather than depleted. Over time, this leads to soil that becomes richer and more productive, rather than exhausted. Another critical advantage is drainage and water management. Raised beds naturally elevate plant roots above ground level, preventing waterlogging during heavy rains. At the same time, they retain enough moisture to sustain crops during dry periods. This balance is incredibly important, especially in regions with unpredictable weather patterns. Modern systems often rely on irrigation infrastructure to achieve similar results, but that requires energy, maintenance, and consistent water supply. Indigenous systems achieve it through design alone. There's also the issue of compaction, which is a major problem in industrial agriculture. Heavy machinery compresses soil, reducing airflow and limiting root growth. Over time, this leads to decreased productivity and increased reliance on chemical inputs to compensate. Raised bed systems avoid this entirely. Because the beds are typically worked by hand and not walked on, the soil remains loose and aerated. This allows roots to grow deeper, access more nutrients, and support healthier plants overall. Plant diversity is another area where indigenous systems have a clear advantage. Instead of monocropping, growing a single crop over large areas, these systems often use polyculture, planting multiple species together in ways that complement each other. Some plants fix nitrogen in the soil, others provide shade, and some repel pests. This reduces the need for synthetic fertilizers and pesticides, while also increasing overall yield stability. If one crop fails, others can still thrive, reducing the risk of total loss. Modern agriculture, by contrast, often prioritizes uniformity. Fields are planted with a single crop, optimized for mechanized harvesting and standardized inputs. While this can produce high yields in the short term, it creates vulnerabilities. Pests can spread rapidly through uniform crops. Soil nutrients are depleted more quickly, and the system becomes heavily dependent on external inputs to maintain productivity. Indigenous raised bed systems, with their built-in diversity and resilience, avoid many of these issues. Labor efficiency is another point of comparison that is often misunderstood. Industrial systems rely on machines to reduce labor, but that efficiency comes with trade-offs: fuel costs, maintenance, and environmental impact. Indigenous systems are more labor-intensive initially, especially during construction, but once established, they require less ongoing intervention. The natural processes built into the system handle much of the work: nutrient cycling, water regulation, pest control. Over time, this can result in a more sustainable balance between effort and output. Climate resilience is perhaps the most important factor in today's context. As weather patterns become more unpredictable, systems that can adapt to extremes become invaluable. Raised beds provide a buffer against both flooding and drought. The increased soil organic matter improves water retention, while the elevated structure prevents root damage during heavy rains. In contrast, many modern systems are optimized for stable conditions and can struggle when those conditions change. There's also a deeper principle at work here, one that goes beyond specific techniques. Indigenous agricultural systems are designed with an understanding of limits. They operate within the carrying capacity of the land, ensuring that resources are not overexploited. Modern systems, driven by demand and scalability, often push those limits, extracting maximum output in the short term without always accounting for long-term consequences. This difference in philosophy is reflected in the outcomes. One system builds fertility over time, while the other often requires constant inputs to maintain it. Another overlooked advantage is energy efficiency. Industrial agriculture is heavily dependent on fossil fuels for machinery, transportation, and the production of fertilizers and pesticides. Indigenous raised bed systems rely far less on external energy sources. They use locally available materials, human labor, and natural processes. This not only reduces environmental impact, but also increases independence from external supply chains. In a world where energy costs and availability can fluctuate, this becomes a significant advantage. It's also worth considering how these systems scale. Modern agriculture scales horizontally: more land, more inputs, more machinery. Indigenous systems often scale vertically and intensively, maximizing productivity within a given area. Raised beds increase planting density, improve soil conditions, and allow for multiple harvests per year. This can result in surprisingly high yields from relatively small plots of land, especially when managed carefully. The concept of time is another critical difference. Industrial systems are often evaluated on annual output. How much can be produced in a single season? Indigenous systems are evaluated over generations. Soil is not just a resource to be used, but something to be maintained and improved for future use. This long-term perspective changes how decisions are made. Short-term gains are weighed against long-term sustainability, leading to practices that may seem slower initially but prove more effective over decades. There's also a cultural dimension that cannot be ignored. These systems are not just technical solutions. They are part of broader knowledge systems that include ecological understanding, seasonal cycles, and community practices. This knowledge is often passed down through generations, refined through experience rather than formal research. While modern science is beginning to validate many of these practices, they were effective long before they were formally studied. In recent years, there has been a growing recognition of the value of these systems. Researchers and farmers are increasingly looking at indigenous practices for inspiration, especially in the context of sustainable agriculture. Raised beds, composting, crop rotation, and polyculture are being reintroduced or adapted in modern contexts. This is not a rejection of technology, but a blending of approaches, combining traditional knowledge with modern tools to create more resilient systems. But even as these ideas gain traction, the core lesson remains the same. Efficiency is not just about output, it's about balance. It's about creating systems that can sustain themselves over time, with minimal external inputs and maximum resilience. Indigenous raised bed designs achieve this not through complexity, but through integration, aligning with natural processes rather than working against them. And that's why they continue to outperform many modern planting systems, especially when evaluated over the long term. Not because they are perfect, but because they are adaptive, efficient, and deeply connected to the environments they operate in. In a world increasingly defined by uncertainty, climate change, resource constraints, and shifting ecosystems, those qualities matter more than ever. Because the future of agriculture may not lie in pushing systems harder. Water systems within raised bed agriculture also demonstrate a level of sophistication that is difficult to replicate with purely mechanical solutions. The channels surrounding raised beds do more than provide irrigation. They act as dynamic reservoirs that respond to rainfall, evaporation, and plant uptake. During heavy rains, excess water is absorbed and redistributed, preventing flooding. During dry periods, stored water is gradually released back into the soil. This natural regulation reduces both water waste and the risk of crop damage. It's a form of passive infrastructure. No pumps, no pipes, no external energy, yet highly effective. And then there is the question of longevity, which is perhaps the most compelling argument in favor of these systems. Many indigenous raised bed systems were maintained and used continuously for generations, sometimes centuries, without a decline in productivity. That alone challenges the assumption that intensive farming inevitably leads to soil exhaustion. It proves that with the right design and management, land can be both highly productive and sustainable over long periods. Modern systems, even highly efficient ones, often struggle to maintain soil health over similar timescales without significant intervention. There's also a philosophical shift embedded in these practices that has practical consequences. Indigenous approaches tend to view land not as a commodity, but as a relationship. This perspective influences how resources are used, how waste is handled, and how decisions are made. It encourages stewardship rather than exploitation. While this may seem abstract, it translates into tangible outcomes: healthier soil, more stable ecosystems, and more consistent yields over time. Modern systems, driven by economic pressures and short-term returns, often lack this perspective, which can lead to practices that prioritize immediate output over long-term viability. At the same time, it is important to acknowledge that scaling these systems to meet global food demand presents challenges. Industrial agriculture has achieved its dominance largely because of its ability to produce large quantities of food quickly and consistently. Indigenous systems, while highly efficient at smaller scales, require more localized knowledge and labor. However, this does not mean they are incompatible with larger systems. Instead, it suggests a hybrid approach, integrating the principles of raised bed design, soil regeneration, and ecological balance into broader agricultural frameworks. This could involve decentralized production, regional adaptation, and a shift towards systems that prioritize resilience alongside output. Ultimately, the continued relevance of indigenous raised bed designs is not an argument against modern agriculture, but a reminder that progress is not always about replacement. Sometimes it's about rediscovery. These systems offer insights that are increasingly valuable in a world facing environmental uncertainty and resource constraints. They demonstrate that efficiency can be achieved through harmony rather than control, through adaptation rather than domination. And perhaps most importantly, they show that sustainability is not a limitation. It's a design principle. A system that sustains itself over time is not less advanced. It is more complete. It accounts for variables that short-term optimization ignores. It balances productivity with preservation. It produces not just crops, but continuity. Because in the long run, the most successful agricultural system is not the one that produces the most in a single season. It's the one that can keep producing season after season without breaking down. And that is exactly what these systems were built to do.